All right, hello everyone and welcome to this video. This is a very special video because I'm going to be talking about a topic that I think is detail oriented, but also I'm going to be talking about one of my favorite YouTubers. He's working on a very interesting project, James Alofts from the Wild Homestead. Um, He's been working on a project. I literally just finished watching his episode, and he encountered an issue with installing one of the concrete anchors, and the amount of dedication to get the anchor done right is very inspiring, to be honest. I had to make this video. I hope you're watching, James. I'm trying to explain why the concrete pillar, the pile, cracked when installing the anchor bolt. So, with your permission, I want to say why I think the concrete cracked when installing an concrete anchor bolt. So, there are three types of anchor bolts that you can fasten connections to concrete. And James pretty much used all three of them. This is actually very remarkable. It shows that you're not willing to take corners. The amount of effort put to get it right, it's so interesting. So I included here three types of anchors. The first one here, this is basically the cast in place, and that was eventually the solution that worked. I think now the way you have it in the last episode, James, is solid. The first attempt was with this type of anchor. It's called mechanical anchor. You basically drill a hole and you hammer that bolt in it, and when you tighten it, it expands at the bottom. This part here at the bottom expands, and then it's not going anywhere. You can't get it out anymore. The third type here, this is called a chemical anchor or adhesive anchor. You same thing. You drill a hole, but rather than relying on a mechanical action at the bottom, you just fill it with adhesive, and then you put the anchor, and the adhesive locks, creates bond with the concrete and the bolt, and same thing, very very secure. So again, as I mentioned, with your permission, James, I want to talk about your project. So this is the ATV garage you're trying to build. This is James' channel, Wild Homestead. Very, very interesting endeavor what you're doing, and I find myself watching your show for hours, and I think there are few things that I really like about what you're doing. This example I picked shows that you're not taking corners. You've put so much effort into that one anchor. It's remarkable. It shows that you're committed to creating good work, and you're not going to cut corners. You're going to create solid work. The second thing is your attention to detail. So this is a connection between the foundation and the upper structure. Even though it's a lightweight, small shed, I know you talk a lot about the snow buildup, um, but even with that, you choose to maybe like it's on the over design side, but nonetheless, the amount of attention you pay to every little detail and how you research it kind of resonates with me. Like, I teach engineering, and I'm a professional engineer. So when I see someone willing to put in the effort and to pay attention to details, and also appreciate structural engineering. So this is something I hear you talk a lot. I hear you consulting with a structural engineer. You take the structural integrity into account. this is something that resonates a lot with me. Like I spent my entire career into structural engineering, teaching it and consulting as a professional. So I have more to say about this towards the end of my video. What I did to help people understand the basics of structural engineering. Um, so let's move on to actually what I want to say, what the reason for the failure happened. So it's worth very quickly talking about the different types of anchor failures. So an anchor in um, concrete could fail in pretty much three different ways. And we're talking about any of the three types. The cast in place, the mechanical, the adhesive, the chemical anchor. So the first one is in tension force. So this happens if there is an upward force on the base plate. So the base plate you're trying to install, if the structure has an uplift and it's causing tension on it, it could break out, pull out of the concrete. It will take a chunk of the concrete with it. Obviously, this has to be very large force to break off this concrete or cause tension failure in the steel itself. So that will take a lot of force to do that. But I think a partial reason of why the concrete failed, I'll show you what happened when we get to the pictures and what James tried to accomplish. But if you have an edge distance, your anchor is pretty close to the edge, that could cause a type of failure when you, especially when you tighten it. When you tighten it too much, it creates up force due to the tying the knot, and it's called a face breakout or a face blowout failure. So the bottom part is going to cause a chunk of the concrete to kind of push sideways. That's not exactly what happened. We'll see one of the attempts to install the anchor. A crack on the top of the pile, on the concrete pile, happened. So I think it has to do with a combination of this side face blowout mode of failure and shear load. So a shear load is basically a horizontal force applied on the top of the anchor, and I think this happened because James was not happy with the anchor at the very first attempt, the one with the mechanical anchor, and tried to remove it. So he used actually a sledgehammer to kind of I don't know, he was trying to pull it out, I guess, but the moment I saw that, I thought this anchor is going nowhere. It will have to destroy the concrete pile to be removed. But I think that force caused this kind of failure, the concrete breakout, which again has to do with the edge distance. So if the anchor is pretty close to the edge, it will cause that type of failure. All right, so I took these photos from your video, James. I hope you're okay with that. I think you're doing great work, and this just shows how much effort and dedication you're doing to get it right, even for just one anchor. The first type is the mechanical anchor, and it's mechanical because of this part at the bottom. You drill a hole, step number one. So this was done right, no problem. And then you insert that anchor, and then you hammer it. So James was hammering it here, and then as you do so, this sleeve will push on that wedge, and then we'll create this side wedge, making it pretty much impossible for that thing to go up again without pulling out a chunk of the concrete with it. So um, something happened here, and it actually, yeah, James was wondering around it why this happened. Um, the anchor was loose. When the post was put on it, it was wobbly. It did not, I think, fully develop, or the diameter. James also talked about this. Maybe the diameter was too tight. He should have kind of drilled a slightly bigger diameter. But um, to be honest, when I was watching the episode as at this point, I thought, you know what? This is not going to be the end of the world. With the lightweight of the structure, the post might be okay. But here you can start to see that James is all about solid work. He did not accept that. So kudos to you, James. That's very impressive actually. And he decided to fix it. But in my opinion, fixing it made it worse. And 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 when that happened, you can see here the sludge hammer. So James was trying to kind of remove the anchor, but that wasn't going to happen. That thing is wedged, developed into the concrete. Um, my theory here, like this force acting on the top of the wedge, I think it's creating that breakout failure. But he managed to kind of use a saw and cut off the top and moved on to try to fix the issue. So this is the second attempt. As I mentioned, James actually used all three types of anchors. Good job. No, seriously, this shows. I was very impressed. Like when it got to this point, you can see a crack here. You can see a crack here. I thought, okay, now I'm not sure what's going on because I see James is trying to fix it, but a damage in the concrete that's worse than a wobbly base plate. So the second type, the adhesive, the way it works, same thing. You drill a hole, but rather than relying on a bottom mechanical fixture that creates a wedge, you can see it's just a threaded rod. So you fill the hole with adhesive. And that's what James did. So this step, no problem. And I think he was happy with this bracket, how the openings kind of fit to accommodate the new location. So you can see the old anchor, now a new opening filled with the adhesive. And now when a combination, I think, from the side hammering, the shear force, and tightening the second anchor with the adhesive type anchor, a crack formed here. So because of that force, I think that wedge of concrete split. And at this point, I think the pile is structurally compromised, and I was very curious what's gonna happen next, what James is gonna do next. And what he did next really impressed me. I've never seen anyone go that far to fix a problem, even for one anchor. So I'm gonna link the links for the episodes, you guys. Like, I really enjoy watching his work. So look what happened. He removed the concrete pile altogether. I don't think I've ever seen someone do that. Like, I was wondering, how is this gonna be fixed? And he's very excited because he got a new tractor, and that was an excellent use to put that tractor to good use. Remove the concrete altogether. And now look at that final solution. I think you nailed it. I think that thing will last for a very long time. So first of all, the use of the sonotube here, excellent, excellent work. This is one of the very first things that I noticed about the structural building that James does. He pays attention to detail, and when I saw the sonotube, this is excellent application for like concrete piles, because you don't want the concrete to be poured in just a hole that will bond with the soil around it. So if the soil freeze, or if there is like a movement of the soil, it could take the pile with it. But the sonotube kind of creates that buffer. It will let the soil slip around the pile, which is the way it should be. So excellent use of the pile of the concrete. And then he mentioned that it doesn't go all the way to the ground. So when you pull it up a little bit, it allow the concrete underneath the tube to spread in the void underneath it, so it will create a wider footing to distribute the load. Again, excellent. And look at the final product. So he used the third type of anchors, which is the cast in place. I got this from the Simpson Strong Tie products. It has a piece of rebar that you set in the fresh concrete. So fresh concrete, check. The cast in place anchor, look how centered that thing is. Oh my God, the edge distance now, no problem, no problem. That anchor is centered in the pile, and I don't think this base plate is going anywhere. So great job. That's all what I wanted to say. I want to share one more thing the reason why I made this video and I wanted to add and contribute is because of my passion about structural engineering. When I see someone trying to do good work, understand how structures works, and pay attention to detail, my partner and I, Noah Moskovich, we created a course about structural engineering basics that doesn't require any kind of degree in engineering or doesn't go too much into crunching numbers. It summarized the basics of the structural engineering. So some people might think, do I need to hire an engineer? I don't understand their language. So what we did is we summarized what you need to know about structural engineering in case you own a structure, you work with structural engineers, you work with architects. So we talk about loads, we talk about construction materials, building with wood, with concrete, with steel. We have tips for owners, for contractors, for builders, and things like that. So I wanted to put this out there and get you to try it, James, and share the course with your audience. So I've put our contact information here, and I hope we keep this conversation going. Will continue to watch your show, and all the best. All right, see ya.